Hello everyone and welcome to a new video wherein I have got this problem which says to evaluate summation k runs from 0 to n just k times cos k theta. Uh, it's a very beautiful problem, a very simple but an elegant solution. Make sure you give it a try before looking at my solution. So let's begin. I'm gonna first define this as some c, and that's n just k cos k theta. Now if we observe carefully, the problem is not with this n choose k term, the problem is with this cos k theta term. And it's very difficult to get in the first try. But if you observe carefully, or this is actually a trick, you can say whenever you see something like cos k theta or sin k theta, something like that, and there are summations or something which you can't think of in any other way, think of complex numbers. And you will be able to solve the problems majority of the time. So I'm going to define S as the same thing except for the fact that instead of cos k theta we have sin k theta. Now what happens by doing this is that I can define a complex number z which is c plus iota s, which is nothing but summation k running from 0 to n choose k times cos of k theta plus iota sin of k theta. And this can be written in a simplified form as n choose k times e to the power iota k theta. And if you carefully observe, this is nothing but an expansion of 1 plus e to the power iota theta. If you're not able to observe it, you can expand this and see, like we get first term as n choose 0 plus n choose 1 e to the power iota theta and n choose 2 e to the power 2 iota theta and so on up till n choose n e to the power iota n theta. So this is nothing but the expansion of binomial expansion of 1 plus e to the power iota theta to the power n. And now we have simplified our problem. Let's simplify it further. Let's write e to the power iota theta as cos theta plus iota sin theta to the power n. And we know that 1 plus cos theta is nothing but 2 cos square theta by 2, and sin theta is 2 times sin theta by 2 cos theta by 2, and that's whole to the power n. Let's pull out 2 cos theta by 2, so that's 2 to the power n cos to the power n theta by 2 times cos theta by 2 plus iota sin theta by 2 whole to the power n. Now what we get here is now what we're going to be using is de Moivre's theorem, which states that cos of theta plus iota sin theta whole to the power n can be written as cos of n theta plus iota sin n theta, a very basic property or a theorem actually. So over here we're using this particular thing, so let's mark this is the main thing that we're going to be using now. And now let's come back to the problem. We're going to write this as 2 to the power n cos to the power n theta by 2 times cos n theta by 2 plus iota sin n theta by 2. And we're just done with the problem. Why? Because remember that whatever we have simplified is nothing but c plus iota s, and if we now all we have to do is compare the imaginary and real part on the right and left hand side. So if I write the RHS in a more simpler way so that we can compare the imaginary and real part, we get something like this plus 2 to the power n cos to the power n theta by 2 times sine theta n theta by 2 and iota over here. So now if we compare the real and imaginary parts, we get C as this whole term, which is 2 to the power n cos to the power n theta by 2 times cos to the power n theta by 2. And in fact, we also get S, which is the imaginary part, which is 2 to the power n cos to the power n theta by 2 times sine of n theta by 2. So instead of getting just one thing that we had to find, we got two things, and this is the result that we have gotten. So a very simple solution, as you could see, just the usage of complex numbers was the trick, and you'll be done with the problem in a few minutes. So that's it for the video. Hope you enjoyed it, and I'll see you in the next one.